So first question is, a 30-meter long transmission line with a characteristic impedance Z0 equal to 20 plus J 40 ohm is matched to the load impedance ZL as shown in the figure below. Then the input impedance is what? See, the condition is given, characteristic impedance is matched to the load impedance, means Z0 is equal to ZL. If Z0 equal to ZL, the input impedance of the transmission line is Zin equal to Z0 into ZL plus J Z0 tan beta L by Z0 plus J ZL tan beta L. If Z0 equal to ZL, the numerator becomes denominator, so both will be cancelled out. So the input impedance of the transmission line is Z0, which is characteristic impedance. So option D will be the correct for a given question. Second question. The dominant mode in a rectangular waveguide with the condition A greater than B, where A and B being the length and breadth of the waveguide cross section respectively. So it is asking that the dominant mode of a rectangular waveguide. So there is a date point. The dominant mode for rectangular waveguide is TE10 mode. Right? So TE10 mode will be the dominant mode for a given rectangular waveguide with the condition A greater than B. So what is the dominant mode? The mode which having the least cutoff frequency. So in rectangular waveguide, TE10 mode will having the least cutoff frequency. It's a standard question. Now next, the radiation resistance of a half wavelength dipole antenna is, again the direct question asked. For half wavelength dipole antenna, radiation resistance will be 73 ohm. For quarter wavelength dipole antenna, the radiation resistance will be 36.5 ohm. It's a direct question, you just remember. Next question is, which of the following, fourth question, which of the following is not a Maxwell equation? If you observe the four options given, first option is del dot d bar is equal to rho, which is the Gauss line electrostatics, which is correct, one of the Maxwell equation. Second option, del cross E bar is equal to minus dou V by dou D, which is Faraday's law, right? Which is also Maxwell equation, correct. Third option, del cross H equal to Jc plus dou D by dou D, which is Ampere's law, is also Maxwell equation. And fourth option, if you observe, del cross V bar equal to minus dou E by dou D, which is not a correct Maxwell equations. What is the correct Maxwell equation? Del dot V bar equal to 0 will be the correct Maxwell equation. So option 4 will be the correct answer. Now fifth question. A rectangular waveguide filled with dielectric epsilon equal to epsilon 1 into epsilon naught, mu equal to mu naught, and the cutoff wave number is Kc. If the relative permittivity of the medium is doubled, then the cutoff wave number is dash. See, the formula for cutoff wave number in rectangular waveguide is Kc is equal to under root m pi by a whole square plus n pi by b whole square, which is the cutoff wave number in rectangular waveguide is independent of permittivity. So if the permittivity is double, the cutoff wave number won't be changed. It is independent of Kc. Cutoff wave number is independent of permittivity. Okay. So the correct answer is, even though the permittivity changes, cutoff wave number won't be changed. The correct option is Kc. The next question is, if f is the frequency of operation, the skin depth of the conducting medium is proportional to dash. The formula for skin depth formula is what? Del is equal to 1 by under root pi f mu sigma. So the skin depth is inversely proportional to under root of frequency. So the correct option is D is the correct option. Now next, the input impedance of a short circuited quarter wavelength transmission line will be, first option is 0, second is cannot be determined, third option infinite, fourth is depends on the characteristic impedance. See, the formula for short circuited input impedance formula is ZSE, Z in equal or Z short circuited. When the load ZSE nothing but short circuited input impedance. That means when the load is short circuited, the input impedance formula is J Z0 tan beta L. Here beta is the phase constant, L is the length of the transmission line. So length is given, which is quarter wavelength is mentioned. So if you substitute J Z naught tan beta is the 2 pi by lambda phase constant, L is the lambda by 4. So lambda will cancel out 2 2. So it is tan pi by 2. So tan pi by 2 value is infinite. So overall it is infinite. So what is the value? Short circuited quarter wavelength transmission line having the input impedance is infinite. So option C will be the correct answer. Right. Now move to the next question. A stepping index fiber has core diameter is 40 micrometer with core refractive index of 1.3 and the numerical aperture is 0.5. Then the refractive index of the cladding is dash. See, numerical aperture formula is what NA equal to under root N1 square minus N2 square, where N1 is the refractive index of the core, N2 is the refractive index of the cladding, and NA is given, numerical aperture is given, N1 is given, asking to find N2. So substitute, we will get the N2 value as 1.2. So option A will be the correct. Next question. Which of the following field quantity has its normal component always continuous at the interface of two media? See, the question is on the boundary conditions. So what are the boundary conditions in electrostatics? Boundary conditions what? First is E1t is equal to E2t. That means the tangential component of electric field is continuous to in medium 1 is continuous to medium 2, or tangential component of electric field is continuous at the interface. Second is D1n minus D2n is equal to OS. That means electric flux density, normal component of electric flux density are discontinuous at the interface. Third is, this is magnetostatics. These two are the magnetostatics. Boundary condition in magnetostatics. H1t minus H2t is equal to J, which is the tangential component of magnetic field intensity are discontinuous at the interface. The second one is B1n equal to B2n. That means the normal component of magnetic flux densities are continuous at the interface. So according to the question, which of the field component having its normal component always continuous at the interface means magnetic flux density is the component having the its normal components always continuous at the interface. Next question. So 10th question. In free space, the electric field is given 10 to the power of 3 sin omega t minus beta z Ay. Magnetic field will be dash. So option A is 0. Option B is minus 10 to the power of 3 sin omega t minus beta z by 120 pi. Option C is 120 pi into sin omega t minus beta z. Option D is 10 to the power of 3 sin omega t minus beta z by 120 pi. So electric field is given. The magnetic field formula is H bar is equal to E by eta, where eta is intrinsic impedance of the medium. If the medium is free space, eta value is 120 pi. Here the medium is mentioned, it is free space. So the eta value will be 120 pi. So now if you substitute, H bar is equal to 10 to the power of 3 by 120 pi sin omega t minus beta z. So the direction will be what? From this we can come to know the direction of the any field. This is a standard notation. Electric field direction cross magnetic field direction is equal to wave propagation direction. This condition has to be satisfied. Here the wave propagation direction is mentioned from this. If you observe from the electric field, the direction is minus omega t minus beta z means minus z given means the wave propagation direction will be positive Az. Okay, so positive Az, and electric field direction also given positive Ay. Ay ఇక్కడ Az is there. So to satisfy this, minus Ax will be the magnetic field direction. So here minus Ax comes. So H bar overall is minus 10 to the power of 3 sin omega t minus beta z by 120 by Ax. So option B will be satisfying. Here the direction is not mentioned but sign is given. So these are the questions asked in Transco 2018 EC paper. Okay. So meanwhile, I will do other questions also. We'll solve all the questions asked in the 2018 question paper. Thank you.